Russia just destroyed their only launch pad capable of sending crews to the ISS. A service cabin wasn't locked down properly. When the Soyuz engines fired, it got ripped off and shattered in the flame trench. Now they're completely grounded. What does this mean when Russian modules are already leaking air and cracking apart? SpaceX, the company Russia once laughed at, is now their only lifeline. How did this ironic reversal happen so fast? Let's dive right in. To understand how we got here, we need to go back to 2009. NASA originally planned to retire the ISS by 2016 due to structural fatigue from orbital temperature cycles and constant dynamic loads. The station was wearing out fast. So why is it still operational nearly a decade past its expiration date? The official answer is that NASA wants to extract maximum scientific value. But there's a more strategic reason that rarely gets discussed. In 2010, China announced plans for the Tiangong space station. If the ISS shut down too early, it would create a vacuum in low Earth orbit, one that China could dominate unopposed. The ISS partners couldn't let that happen. What price are they paying to maintain this aging outpost? Here's the reality. Every crew rotation and cargo flight now carries 20 to 30% of its payload dedicated purely to station maintenance. We're not talking about experiments or supplies, we're talking about home repair. New rollout solar arrays called IROSA, upgraded CO2 scrubbers, fresh oxygen generation equipment, special sealants for sealing cracks. The ISS is essentially being rebuilt piece by piece in orbit, and without these constant upgrades, it would have collapsed years ago. But not all modules can be saved. The Russian segment, built in the late 1990s, is suffering the worst. Zvezda, the core Russian module providing oxygen, power, and propulsion, started showing cracks in 2018. Air leakage climbed from 200 to 300 grams per day to 400 to 600 grams per day by 2025. Roscosmos tried everything: epoxy sealant, titanium patches, special clamps installed during spacewalks. Nothing worked. New cracks keep appearing. How long can they patch a sinking ship? Then there's Zarya, the very first ISS module launched in 1998. In 2021, engineers discovered surface fractures spreading across its hull. They haven't caused catastrophic failure yet, but the risk is real and growing. The only solution so far? Constant monitoring. No permanent fix exists. By 2021, technical assessments from Roscosmos and RSC Energia delivered a chilling verdict. Roughly 80% of Russian segment systems had outlived their original 10 to 15-year design life. Vladimir Solovyov, Energia's chief engineer, stated bluntly that once these systems are fully exhausted, unrepairable failures may begin. By 2023, Roscosmos CEO Yuri Borisov confirmed what everyone feared. Most Russian ISS hardware is now beyond warranty, and a wave of failures is expected after 2025. This wasn't speculation. It was a prediction based on hard engineering data. That's why Russia decided to pull out of the ISS partnership in 2028 instead of 2030, to limit liability for these aging, failing systems. And then came the accident that changed everything. During the recent Soyuz MS-28 launch at Baikonur, something went catastrophically wrong. The Launchpad, in service since the 1960s, has a massive service cabin that rides on rails underneath the rocket. Technicians use it to access the engines, hook up cables, and handle ignition prep. Before launch, this cabin is supposed to lock into a hidden position below the flame trench. But on this day, someone failed to secure it properly. When the Soyuz engines ignited, the exhaust created a low-pressure zone that pulled the cabin out of position. Its front heat shield acted like a sail, catching the airflow. The entire structure ripped off the rails and was thrown into the flame trench, where it shattered on impact. What does it mean when your only ISS launch pad is destroyed in a preventable accident? The damage is severe. Roscosmos claims repairs will take just a few weeks, but independent experts say full restoration will require at least 6 months. That's not spin, that's physics. You can't rush structural repairs on a 60-year-old launch facility. And during this time, Russia has zero capability to send crews or cargo to the ISS. The upcoming Progress resupply mission scheduled for December? Delayed indefinitely. No new experiments, no fresh food, no spare parts. Now here's where it gets dangerous. If any Russian module experiences a critical failure during this blackout period, another air leak, a power system breakdown, a propulsion malfunction, the crew will have to rely entirely on whatever tools and hardware are already on board. There's no cavalry coming. Can 7 astronauts survive on a station that's slowly falling apart with no resupply? NASA and Roscosmos have emergency procedures ready. If cracks in Zvezda or Zarya worsen and cause uncontrolled air leaks, pressure sensors would detect it immediately. The crew would prioritize evacuation to the American segment and seal the hatches connecting Russian modules to the rest of the station. This isolates the leak and prevents it from spreading. Roscosmos would attempt repairs from inside, though fixing decades-old systems is nearly impossible. If the leak exceeds a critical threshold, those hatches would be sealed permanently. That would limit ISS operations, reduce available docking ports, and increase fuel demand to maintain orbit. But research could continue in the U.S. segment with support from commercial spacecraft. In the absolute worst-case scenario, if the entire station faced collapse or depressurization, both American and Russian crew would evacuate using Crew Dragon. Wait, Russian astronauts flying on Dragon? That raises another problem. Just recently, Russian cosmonaut Oleg Artemyev was removed from the Crew 12 mission set to launch in early 2026 on SpaceX Crew Dragon. The reason? Alleged violations of ITAR, International Traffic in Arms Regulations. Artemyev reportedly took photos of SpaceX engines and sensitive documents at their Hawthorne, California facility, potentially to copy technology. NASA and Roscosmos replaced him with Andrei Fedyaev. This isn't being treated as official espionage, but rather an industrial security breach. Was it personal curiosity or pressure from Roscosmos to catch up with the company they once mocked? Back in the 2000s, when Elon Musk tried to buy Russian rocket engines, they literally laughed him out of Moscow. Now that same company controls access to the ISS. The irony is almost painful. Since Crew Dragon became operational with Crew 1 in November 2020, SpaceX has completely shattered the nearly 2-decade Soyuz monopoly. Between 2011 and 2020, NASA paid an average of $80 to $90 million per Soyuz seat, over $4 billion total flowing straight into Roscosmos coffers. Dragon cut that cost to $55 to $60 million per seat, saving NASA at least $1.5 to $2 billion so far. But the money is just the beginning. Dragon isn't just replacing seats, it's taking over critical tasks only Russia used to handle. Since 2023, Cargo Dragon has been performing reboosts using upgraded Draco engines, lifting the ISS without needing Zvezda. By December 2025, Dragon had completed 7 independent reboosts, each raising orbit by 1 to 2 kilometers. Translation? The U.S. could maintain the ISS for 6 to 9 months without a single Russian spacecraft. In August 2025, NASA and SpaceX tested a minimum lifeboat scenario. One Crew Dragon could evacuate all 7 astronauts in under 45 minutes. No need to wait for both Soyuz and Dragon. And now, with Baikonur's Site 31 pad offline indefinitely, SpaceX isn't just an alternative. It's Roscosmos' only lifeline. If this situation drags past March 2026, we could witness something unthinkable just a decade ago. A Crew Dragon lifting off from Florida, carrying Russian cosmonauts to save the Russian segment of the ISS. The company Russia dismissed as amateurs would be rescuing the space program that once dominated low Earth orbit. How did the roles reverse so completely? So what does all this mean for the future? In less than 5 years, the entire power dynamic in space has flipped. Russia once charged NASA $90 million per seat and controlled the only ride to orbit. Today, they're grounded with a destroyed Launchpad, aging modules leaking air, and no backup plan. SpaceX, the company they dismissed as inexperienced, now holds the keys to the ISS. This isn't just about one accident or one company's success. It's about what happens when you stop innovating and rest on past achievements. Russia built the foundation of human spaceflight, but they didn't evolve with the times. Meanwhile, SpaceX pushed boundaries, took risks, and fundamentally changed how we access space. The result? a complete reversal that nobody predicted a decade ago. The ISS has maybe 3 to 5 years left before planned deorbit. Russia's modules won't last that long without constant resupply and repairs, and right now they can't deliver either. Will they swallow their pride and buy seats on Dragon? Will the Baikonur pad be restored in time? Or are we watching the end of Russia's ISS partnership happening in real time? One thing is certain, space exploration waits for no one. Those who adapt survive. Those who don't become footnotes in history. What do you think happens next? Drop your predictions in the comments below. If you found this breakdown valuable, hit that like button and share it with anyone interested in space. And subscribe to Space Update 24 Hours for more real analysis of what's actually happening beyond Earth. We'll keep you updated as this situation develops.